What if life doesn't actually need a star? In this video, I'll try to create a moon that can stay warm and potentially habitable even in the total darkness of space. No sun, just the tidal forces of a gas giant and friction within the moon's core. Let's see if such a world is actually possible in the Universe Sandbox simulator. I've started an empty simulation and placed this gas giant right here. I've customized its colors, and overall, the gas giant turned out quite beautiful. And yes guys, in this simulation, there's only this planet, no stars, nothing at all to illuminate it. But you might ask, what's lighting up the planet then? Let me explain. This light hitting the planet is essentially artificial light, just so we can actually see something. Here in the view settings, I'm showing you that I have this artificial directional light turned on. If I turn it off, then obviously everything will become shrouded in darkness. Next, we need to find the perfect location for a moon around the gas giant, so tidal forces can provide the right temperature for life as we know it. To find this ideal distance, I'll take our planet Earth and use it to locate that ideal and most suitable location. Consider this a preliminary experiment in this video before the main event. In the first case, I'll place Earth at a distance of 75,000 kilometers. Time started, and Earth's movement has begun. I've set it quite close to the planet. Maybe it's within the planet's Roche limit, but let's check now. So far, Earth is doing fine. Now zooming in on Earth, look at what's happening to it. It's being stretched instantly. Massive tsunamis are sweeping across the planet. This is brutal, honestly. Everything is flooding here. I doubt Earth will have good conditions here. And yeah, we see the average temperature is rising very significantly. Now I'll speed up time even more. 15 days pass per second, and we see the temperature rising very sharply. And it's already over 100 degrees Celsius, and Earth is already turning into a molten desert world, you could say. Through the atmosphere and clouds, you can see for yourselves that life simply can't exist here. So now I'll try placing Earth further from the gas giant, at a distance of 100,000 kilometers. Starting the simulation. Again, 15 days pass per second. We see the average temperature is also starting to rise significantly. But at least it's not as fast here. Earth is also being stretched instantly through the atmosphere and clouds. There are tsunamis too, but not as strong as at the 75,000 kilometer distance in the first case. But the Sahara and Africa are still getting completely flooded. Now 1 month passes per second, and the temperature is already 22 degrees Celsius. And overall, the situation on Earth is, well, not great guys. It'll be hot on this orbit too. So we need to move it a bit further, just by 2,500 kilometers, making the distance 102,500 kilometers. In the simulator, if you place Earth like this, it says the distance is this much. But if you check Earth's properties, the distance listed there is different, 40,493 kilometers. I would assume this is because when you orbit Earth, the system displays the specific distance from the gas giant's center, but the object properties menu shows it from the edge, something like that. 1 month passes per second, and we see that the temperature is still rising slightly in this orbit. Well, let some time pass, and then we'll see what the final result will be. As you saw guys, the temperature rose very slowly, time was fast forwarded, I sat and waited for a long time. Well, for you, it was all much faster. Anyway, here's Earth, this is how it turned out, a bit flattened of course. And we can see that the equator is flooded. The average temperature is now almost 10 degrees Celsius. But I tested it off camera and it reached over 10 degrees and didn't seem to grow any further. Here's one interesting point. The orbital period and the day on Earth have become almost identical. So over time, this gas giant has completely tidally locked our Earth. And now Earth is always facing it with one side. And let's also take a closer look at what we have here on Earth's surface. Because a day on Earth became about 11 hours, Earth spun up around its axis, and water collected at the equator, flooding the territories there. And closer to the poles, on the contrary, there's more land. And this is the picture. There's a bit of vegetation in Europe and along here through Russia. And there's some in North America and a little bit in South America. But many territories have simply become lifeless. Ice remains at the poles, also ice in the Himalayas and ice in Antarctica, but the simulator shows a fairly high probability of life, over 82%. And we can say that we found the perfect location. And now let's proceed to the main part of this experiment. I'll just replace this Earth with another rocky planet, a random planet. I replaced it with this planet. It's composed only of silicate and iron. In terms of mass and radius, the planet is slightly larger than Earth. Next, we need to add water and atmospheric components for life to form. I could launch objects with the necessary components for this. But if I do that, the resulting collisions might slightly disrupt this perfect orbit, and the tidal forces from the gas giant won't be what we need. So to avoid knocking the orbit off, I'll use a different tool. This involves launching individual particles of the components I need. They will fall gently onto the moon without disrupting its trajectory, and the first component I'll launch is nitrogen. The next component I'll launch is oxygen in the amount I need. Now I'll launch argon and carbon dioxide, and I won't forget, of course, to launch water there. And this is how it all looks. Oh, and as soon as the water fell, everything was immediately flooded. 10 days pass per second, and let's watch how this planet transforms. The temperature is steady for now, but the pressure is somehow too high, even though I launched a normal amount of elements. Maybe a lot of water, vapor, went into the atmosphere. Well, yes, that's it. A lot of water went into the atmosphere. For some reason. Well, you see, a simulator bug. Where did 18 Earth oceans come from when I launched one Earth ocean? Anyway, I'll fix this now. I'll set it to one Earth ocean here and remove it completely from the atmosphere. Oh, now that's more like it, and we have some dry land appearing. Well, as we can see, the oxygen, nitrogen and other elements I released haven't spread evenly across the surface yet. To avoid waiting, I can use this button right here to speed things up and distribute them evenly. Aha, look at that. It's still not in any great hurry to spread out. There we go. It seems to have spread now. So some kind of atmosphere has formed already. But the pressure is high, a full 9 atmospheres. But once again, the simulator is acting a bit strange. Where did 4 Earth atmospheres of oxygen come from? And there's more argon and more nitrogen too. From where? How? Oh, to save us the trouble, I'm going to do this. I'll go right here into the composition tab. Down here we have these atmosphere presets. I'll just select Earth and I'll set the pressure and composition here. And then apply this value. Oh, now as you can see we have a reasonable value for the atmospheric composition. I'm wondering if I should add a magnetic field to this moon since there's no star in this system. But radiation can still come from other corners of space. It's probably better to set up a magnetic field for this moon after all. I'll set a strong magnetic field with a strength of 1 Gauss. Here's what happened with the pressure. It's just over 1 atmosphere, which is basically perfect, and the temperature right now is 29 degrees Celsius. Yes, this planet will also eventually become tidally locked to the gas giant, so most of the water will gather at the equator. But there's not much of it here. I don't know if I should add more. Well, let's just leave it like this for now. And I'm noticing I have the vegetation display turned off here, so I'll turn it on, and as we can see once it's displayed, everything turned green instantly. Now that's epic and cool, but guys, let's not celebrate just yet. By speeding up time to 1 month per second, we see the temperature on this moon starting to rise rapidly, and it's already approaching 40 degrees Celsius. That's not very good. In fact, I'd say it's bad. But then there's only one way left to stop the temperature rise on this moon. That's to move this moon a little further away from the gas giant. The orbital period here is listed as just over 11 hours. Let me set the orbital period to 12 hours and see if that helps stop the temperature rise. 10 days are passing every second. And yes, as we can see, the temperature is starting to drop. That's great. And now 1 month is passing every second. So let's see just how low the temperature will drop. I think it's pretty clear by now. The temperature is going to drop way too much. So instead we need to move the moon back a little closer now. I'll strive to establish a happy medium between the previous and current values. Let's manually adjust the orbital period value to exactly 11.6 hours. No, as we can see, even with that orbital period, the temperature keeps falling. Well, then I'll have to move it even closer to the gas giant. I'll set the orbital period value to 11.3 hours. Oh, and this time the temperature has finally started to rise. You see, it's such a delicate balance with the orbit. You have to determine the position perfectly at all to get the absolute ideal temperature. Anyway, let's see what temperature it settles at now. And in this case, the temperature has already risen to 23 degrees Celsius and is still climbing. I think if we wait any longer, it'll get a bit too hot on the moon. So I think the ideal orbital period for this moon would be approximately 11.4 hours, which is just a bit more than that. In this case, as we can see, the temperature starts to drop, but not very quickly. I think that'll be just the perfect value. And finally, everything turned out exactly as I wanted. The temperature is almost 22 degrees Celsius across the entire planet. I think that's an excellent value. That's such an interesting feature when a moon is heated only by tidal forces. And now I'm going to give this planet a much more interesting look. The cloud view settings for this moon clearly show that there is only a single type of cloud present here. But I want to add another type of cloud. Let's go with this one. And this way the moon will look significantly more beautiful and radiant. Now look at the final likelihood of life on this moon. It's over 74%. 30%. I think that's a very good indicator. Considering we have no star here, the planet is heated only by tidal forces. Now I'll descend to the surface of this moon and let's look at the sky to see how the gas giant looks from here. It looks so beautiful here. Cool. Also look, the orbital period and the rotation period are almost identical. So once again, just like with the Earth back then, this moon has become tidally locked to the gas giant and always faces it with one side. Now let's check how all of this will look under realistic lighting. I'm turning off the artificial light, and as we can see, this is the picture we get. There's no star providing light, but we can clearly see the lights of night cities. They're visible across the dark planet, and there are quite a lot of them. It looks really cool, of course. And if we descend to the surface, we only see this massive dark silhouette of the gas giant, which completely obstructs our view of the surrounding stars. But that's the only way the inhabitants of this moon can tell where their parent gas giant is, which provides them with warmth and gives them life. And here's such wonderful beauty when viewed from space. I clicked the button to distribute water evenly across the surface. This is what we got. Obviously, this is a temporary process. Everything will settle back to how it was before, but I just wanted to show you how the planet would look in this case. I also decided it wouldn't hurt to add a haze like Earth's atmosphere. It looks much more interesting this way. And let's set the atmospheric opacity here to about 3%. Oh, and it looks much more beautiful like this. As you can observe here, this moon continues to orbit its gas giant quite stably. As we have observed, even without a star, a moon can stay warm and potentially habitable if tidal forces do their job. If you liked the video, don't forget to give it a like and leave a comment. Thank you very much.